Okay, good morning, everyone, and welcome to the third session of the Matlab course. Basically, it seems I have an issue with my camera here for some reason, but hopefully this is not gonna stop us from delivering the content today. So I'm gonna start by sharing my screen, and I hope that someone can confirm that they see a screen, maybe by raising their hand. So they see a screen, or a whiteboard. Anyone guys can see the screen now?
Yes, we can see it.
Very good. Good. Thank you so much. All right. So let's just briefly recap what we have covered. We basically covered the usage of MATLAB as a calculator. We also discussed basic plotting using arrays. And also, last time, we also went through, started doing programming, basically F statements. And we spent some time covering exercises on this. Today, we want to discuss loops, and in particular, the basic two types of loops available in MATLAB, which are the for loops and the while loops. And let me briefly explain the idea of each one of them on this whiteboard here. So if I write loops in MATLAB, so basically you have two options. You have the so-called for loops and you have the so-called while loops. And maybe I should start first by saying what's the idea of a loop. The idea of a loop is that you need to repeat certain type of a calculation several times, and many times, maybe thousands or millions of times, and you need to keep cycling, iterating until you finish such cyclic or repetitive calculation. And as I said, MATLAB offers you two possibilities, the for loops and the while loops. What is the difference between the two? The for loops are counter-controlled. So these are counter-controlled loops. In other words, you know before the start of the calculation how many times this is going to run. So maybe you know that this is going to run for 100 times, for 1,000 times, for million times, right? So this is counter control, and usually less dangerous because it has a finite end. You know when it is going to end, right? The while loop are a little bit dangerous because they are condition controlled. So these are condition control. And what do I mean by this? Basically, in these loops, you keep looping as long as some criterion is satisfied. And then if this criteria is not satisfied, you break the loop, you get out of the loop. And because of this, the while loops are very, very risky, because before you have to look with your eyes at the code. Is this condition can run forever? Can it run really forever? Because if it can run forever, then that means that your code can run also forever without an infinite stop. And that's usually a dangerous thing, right? So we will start with for loops because they are kind of easier to absorb and understand. And then we will move to the while loop. So what is the syntax of the for loop? So if I move this up a little bit and discuss the syntax of the for loop. So for loop syntax in MATLAB. So the syntax is very easy. So I start with the word for, and in fact, once I write it and give it to MATLAB, automatically it colors in blue, and every for has to come with an end. So it has to come with an end statement. But next to the for itself, you need to write a counter. You can choose whatever letter you want to choose. So let's say I, for example, I that starts from some initial value, let's say 1, and it runs with a step. So there is a step size here. So for example, the default is 1. So if you don't write any step, the default is really 1. So let's say you do this with a stop of 2, and then you end at 50. So the syntax, let's write it again with a different color here. So there is an initial point, an initial value for the counter, a final value for the counter. This is the final value. And in between, there is the step. So if you think about the loop, and of course, between the for and the and, there are a bunch of calculations. So here you have several calculations that you can run. Oops. Why did we lose our whiteboard here? Yeah, we have it back. So between the for and the and, there are a bunch of calculations. So whatever you want to calculate in between. But let's try to follow how many cycles this is going to run. So it's going to start for the case I equals 1. And then you add 2, which is the step. So it becomes 3, and then 5, and then 7, and then 9, and so on until it reaches to what? To 49, and then stops. Because if you add the increment one more time, you get 51. But 51 is greater than the final value, which means that this for loop has to stop because you exceeded the final value. You cannot exceed the final value. Okay, so again, that is the syntax of a for loop in Matlab. You have a complete freedom to, and by the way, you can even have negative steps, so you can go backward. It doesn't have to be going forward all the time. Okay, so that's for the syntax. I have a very, very important note, which I'm gonna say now, and it will show up in one of the exercises, but it's better to start emphasizing this right now. So guys, upon finishing the for loop, because there is a source of confusion here. Many people think that the I variable that exists as a counter for the for loop, many people think of it as an array because of the syntax being very, very close to Matlab, defining a Matlab array. However, this counter, this I here, this little I here, after you finish the loop, is not an array. In fact, it's just a scalar. It just keep, so it starts as 1, and then you erase the 1 from the memory, and then becomes 3, and then you erase the 3 from the memory, and then it becomes 5, and then you erase the 5. And at the very, very end of the loop, the value, if you ask the computer what's the value of the I, it's going to tell you 49. In other words, it is not an array. And you will believe me, this is a major source of error when we deal with these for loops in Matlab. So let's get started with a very, very simple exercise, just, to motivate the idea. And as always, guys, you can either raise hand or interrupt right away with a question if something is unclear. I'm going to open an exercise from our shared drive here. We have, it's the common shared drive that we have been using before. Maybe I can give the link one more time. So copy the link, done, post it in the chat here. Let me stop sharing, post in the chat so that everyone has access to it. It's in the usual shared folder. I'm sharing the screen one more time. So if everything is fine, you should be able to see the exercise here, which says loops in Matlab. Okay, so I'm gonna basically try to address the first exercise, which is write a script that calculates the sum of numbers from 1 to 100, upgrade this script to store and plot the values of the sum as a function of the number of the terms. Although the exercise looks very, very trivial, it's very instructive because it teaches the idea of calculating a sum. So I'm gonna, as we learned, I'm gonna start with a new script. So maybe with a comment, this script calculates the numbers from 1 to 100, and not really calculates the number, calculates the sum of the numbers from 1 to 100 and plots the value of the sum as a function of the number of terms. So that's the idea. Let's save it. We can, as always, start with, clear all and CLC. Okay. And let's save this thing. Let's call it basic sum and save here. Okay. Obviously here, since I want to repeat a calculation 100 times, I have to loop. You know, whenever you see something that needs to be repeated several times, that's automatically some sort of a looping. Now, the next decision, is this a for loop or a while loop? Obviously, it's a for, because I know the exact initial value and I know the exact final value of the number of number of cycles that I want to do in this loop. So, and then the idea, as you see, is you need to calculate 1 plus 2 plus 3 plus 4 all the way to plus 100. And the idea of summing, as I said, is very, very essential to many engineering calculations, that it deserves a closer loop here. I'm going to start by defining a variable that I will call sum. Okay, so sum, and I will initialize it by 0. So sum starts as a 0, and then a semicolon to suppress. Then I'm going to do a for loop, choosing the counter as I wish. I'm going to call it A, for example. It's going to start from 1, and it's going to end at 100. And as I said, if you don't specify an increment, then it's automatically 1. I would recommend, whenever you have a for loop, you put an end, just, you know, to make sure that you connect every for with an end. And obviously, you see Matlab here is doing this for you. And actually, it's very nice. Sometimes when you want to write a code, and you know, write a lot of stuff here, you know, you can click on this, and it's hiding what's inside the for loop. So sometimes you want to see the structure of the code without really the need to see what's exactly inside each for or each if statement. If you want to look at it again, you just click on this one more time. Okay. Now, I'm going to start developing this step by step. So I'm going to call sum equals A. And I will put a semicolon here. And before I run my code, I want to ask if can someone maybe check with me here from the audience, would this simple line of codes calculate the sum? Would they calculate actually the sum of the numbers from 1 to 100? Because if you think about it, as the loop moves, you know, starts from 1 to 2 to 3 to 4, sum equals 1, sum equals 2, sum equals 3. So question to you guys, does this calculate the sum, the variable here? Does it actually calculate the sum, or what do you think?
No.
No, Muhammad. So how should I make it calculate the sum?
We add plus. ممكن اتكلم عربي ده صح؟
Yes.
هتكون sum plus equal k. كل مرة بيجمع عليها.
Very good. Excellent. So sum is gonna be sum plus k. Now this is calculating a sum. Because before doing this, it was erasing from the memory the previous value. So it started as 1, and then you erase it from the memory of the computer, and then store 2, and then erase it and store 3. And if you run this and ask the computer what's the value of sum, it's gonna tell you it's 100. It's basically just the last term. But as your colleague said, obviously I need to make it sum equals sum plus k. And let's run this. Let's run this quickly here. Is it taking time? Oh, I'm not printing sum. Sorry, I should have done this. Display sum, for example. Yeah, let's run it. Yeah, that's the sum. 50-50, and that you can confirm by other means that this is actually the correct value of the sum. So that's good. That's a very basic idea. You start of summing. You start with this variable. You can call it sum or anything. You zero it at the beginning and gradually add each term one at a time. Now, I was asked to upgrade this script to store and plot the values of the sum as a function of the number of terms. In other words, let me explain what this is saying, maybe with an annotation here. Let's clear everything. So what this is saying is, look, after I'm trying to calculate 1 plus, plus 2 plus 3 plus 4 and so on. So after one term, the value of the sum is 1. After 2 terms, the value of the sum is 3. After 3 terms, the value of the sum is 6. After 4 terms, the value of the sum is 10. So that's what I want to plot. I want a graph here where the y-axis is the value of the sum, and on the x-axis, how many terms, the number of terms I'm doing this, right? How many terms I reach it to. So I'm gonna do something very, very naive here on the screen, and I hope someone can clarify why it's wrong. So the naive thing, I'm gonna say, well, that's easy. All what I need to do is to say plot k and sum, and I love plotting, so I'm gonna put, I'm gonna make it dashed, I'm gonna make it red, and maybe, with a diamond symbol. And let's close the plotting command. Why this is wrong? Why this calculation is wrong? In fact, if you ask Matlab to run this, I'm pretty sure it's gonna give you an error. Well, it gives you 1 point here. It's actually giving you 1 point where the x, can someone see the figure that came out to the screen? Probably not, probably not. Let me share again. So guys,
yes,
what I did is—
you can see the figure.
You can, perfect, perfect, thank you. So that's the figure that I obtained, and it's very funny because it just shows that when the number of terms is 100, it shows that the value of the sum is 50-50. So what's happening here? Why I'm not seeing a graph, just 1 point?
It showed me the end result because it iterated until it showed me only one result at the end.
One result, yes, excellent. So I don't have an array. I am not storing things in an array. So I would rather store my results in an array. And in fact, I need 2 arrays. One array to represent the x-axis, which is the number of terms, and another array that stores the value of the sum, right? And basically, you can do this. You can do this as follows. Basically, all what I need is 2 arrays. First of all, I'm gonna keep sum equals 0 as an initialization for the variable sum. But to change sum into an array, I'm gonna use the very, very first method we introduced to define an array. If you guys go back to our first session, we said that there's a very tedious method to define an array, which is basically to put it between brackets, right? To define sum and then brackets and say sum of 1. Here, I'm gonna call this sum of k equals sum of k plus k. What this is doing? It's basically generating an array of values. So sum of one, which is the first element of the array sum, okay, is gonna have the value of 0. Actually, this is gonna make a mistake here because I need to start with the very, very first value of the array sum, which is sum of 1. That's the first element in the array. I'm gonna put this 0. And what I'm gonna say is that after sum of 1 is gonna be sum of 1 because it's sum of k and the current value of k is 1. So this is gonna be sum of 1 plus k, and k is 1. But what is the value of sum of 1 so far? I defined it initially to be 0. So this guy is 0. 0 plus 1 is gonna give me 1. So it's gonna store in the first element of the array the value of 1. And then it's calculates sum of 2. And then sum of 2 is sum of 2, which wasn't initialized before. I probably here, I'm making a mistake one more time here because, when it calculates sum of 2, it's gonna ask Matlab, what is the value of sum of 2? And there is nothing because I didn't store sum of 2 in the memory, right? So I should say sum of 2, instead of sum of 2, it has to be sum of 1, right? Which is the previous value. Because of this, I need to make this k minus 1, right? Because let's see, when I'm calculating sum of 2, I need the value of sum of 1, the previous value, which is 1 here. And I'm gonna add on top of it the value of k, which is 2. So now let's correct this. This is not sum of 2, this is sum of 1, plus the current k, and the current k is 2. So sum of 1 is 1 plus 2 is going to give me 3. Similarly, you can keep looping. Sum of 3 is sum of k minus 1. Remember, when it is sum of 3 here, there is sum k minus 1. So it's going to be sum of 2, which I calculated to be 3 in the previous step, plus 3, and that should give me 6, and so on and so forth. So guys, I managed now with this trick of changing sum from being a scalar, a single number, into an array. I'm now able to calculate the sum term by term. Okay. Now, this is defining an array that can be plotted on the y-axis. This is an array that can be plotted on the y-axis, but I need another array on the x-axis that gives me the number of terms. So, for example, after the first term, after the second term, after the third term, and it's really up to you how you want to define this. Just for the sake of revision, I'm going to use the len space. So the array that's going to represent the x-axis, I'm going to call it number of terms, for example. I'm going to use len space that we learned it before. The initial value is 1. The final value is 100. And I need 100 points, right? I need 100 points. So that's it. Now I can plot not k and sum, because again, as we said, k is not an array. I'm going to plot number of terms and sum. Let's try to run this script together and see if it's going to generate any mistake. So it's unhappy. So let's see. It's not running because of the first case. So let's see why it's complaining. It's a good that we debug things together. So it's saying array indices must be positive integers or logical values. And it's complaining because think about it. When I'm calculating sum of 1, it is basically sum of k minus 1, and the first k is 1, which means k minus 1 is going to be 0. So it's going to give me sum of 0. But there is nothing called sum of 0. Because as we said, typically arrays in Matlab starts from 1. So Matlab is unhappy by this. It says indices must be positive. You can treat this with many different ways. I'm just going to suggest one of them. But obviously, there are many ways to fix this. For example, you can calculate sum of 1 outside the loop, by saying sum of 1 equals 1 outside the loop, and the loop itself starts from 2. Just avoid referring to sum of 0, because as we said previously, MATLAB doesn't like arrays to start from 0. MATLAB likes them to start from 1. This way, the first time you go to the loop, I'm gonna calculate sum of 2. And it will say sum of 2 equals sum of 1, which we calculated before the loop, plus the value of k. Let's see if MATLAB is happy now. So I'm gonna clear the annotations here. Let's try to see if it's happy now. Run. Now it's running. Now it's running, and we have a graph. So you see, it starts first with a very small value of the sum, and then as the number of terms increases, so after maybe 50 terms, the value of the sum, as you see here on the screen, is 1275, and then it keeps increasing. You can even read each number by stopping with the mouse here. And finally, the last term, when I have 100 term, the value of the sum is 50/50. Maybe I should do something here. I need to suppress this writing. Maybe I should also put some labels. X label is number of terms, and the Y label here is the sum. And let's close this and run this again. Now it's clear what's happening here. Guys, any question on this exercise? Any questions? Let me see the chat here. Any questions on this exercise? Okay. Just unmute yourself and ask if you know, something is unclear. Very good. All right, so let's actually try another exercise along the same lines. In fact, I'm going to do the same exercise, this one, along the same lines here. Before we actually take something in the breakout rooms, which is this one. The third one is simple, but it's going to be very instructive, and we will do it in the breakout rooms. But I'm going to start with exercise number 2. So let's, this is going to be saved. We need a new script here for exercise 2. So exercise 2 is telling me, we know from calculus, and that's something you can prove by calculus, that 1 over k power 4, if you sum this series to infinity, this is going to give you pi to the power 4 over 90. We don't need to prove this here, but you can use calculus to prove stuff like this. What we are asked to do is to approximate the infinite series by a finite one up to 100 terms. Again, that gives you an idea that we need to loop, and we are going to need to loop 100 times. And guys, as we explained, that the idea of summing is very fundamental, that it appears in many engineering and mathematical cases. And that's one of these cases. I'm trying to calculate a sum of a series. Then I need to plot the relative percent true error as a function of the number of terms. And then there is a little piece here related to adjusting the axes, and I'm going to discuss it at the end. But maybe before this, I will take a second to explain what is meant by the relative percent true error. This is a concept that's very prevailing in engineering and numerical methods in general. Let me just briefly illustrate here for a quick second. Suppose you are calculating something. For example, in this case, you were calculating the sum of the series, and pi power 4 over 90 is the true value. So this is the true value. And suppose you manage to find an approximation for this. Let's say that, you know, whatever, x is an approximate value, which we are going to calculate using Matlab. How do you calculate the error? The error, or the absolute error, is basically the difference between your estimation minus the true value, which is pi power 4 over 90. That in itself is called error. But if I want this to be relative error, then I need to divide this guy by the true value. And if I want to make it a percentage, possibly I need to multiply this by 100. So this has this lengthy name being the absolute because I take the positive value, relative because I'm referring my error to the true value. So it's absolute relative error, and it's a percentage because I'm multiplying by 100. That's basically the idea of the absolute relative error. And in this exercise, let's try to, you know, to decompose it a little bit. I have this series, and I hope many of you guys are familiar with the sigma notation widely used in engineering and in calculus. So basically this series, if I want to decompose it, it starts from k equals 1. So it's 1 over 1 raised to power 4. That's the first term. The second term, when k equals 2, it's 1 over 2 raised to power 4, and then 1 over 3 raised to power 4, and so on and so forth, and supposed to be infinite. But here we are going to use Matlab just to stop at the term number 100, which is 1 over 100 raised to power 4. And then we need to store in the memory of the computer each one of these, right? Each one of these needs to be stored in the memory, or actually not these values, but just the error. So if I stop after the first term, maybe let me clarify this. If I stop after the first term, what's the value of the error? Well, first term, if you calculate it, it's going to be 1. Then the error is going to be 1 minus pi power 4 over 90 over pi power 4 over 90, and then multiply by 100. Suppose I take 2 terms. What's going to be the error? The error is your approximation. Our approximation is 1 plus 1 over 2 to power 4 is 16, minus the true value, which is pi over 4 over 90, divided by pi over 4 over 90, and then take the absolute and multiply by 100. So I need to plot these errors after one term, after two terms, after three terms, and after four terms. So let's try to develop this together. I'm going to go to this script here. Let's call it what? Let's call it, give it this name. Let's call it finite sum. And as always, let's start with clear all. It might be a good idea if you have access to Matlab to start coding with me to, you know, think online right away. What should we do? Well, I need to sum something, right? Because this is a sigma notation, so I need to do some sort of a summation. So as we learned the idea of summing, I'm going to define a variable. I'm going to give it the initial value of 0. And then I have a for loop. It needs to start from 1, it's to at 100, the step of 1, because, you know, I'm summing terms 1, 2, 3, 4, 5, all the way to 100. And every sum needs to have an to calculate the sum. The current value of the sum equals the previous value, as we just learned from the previous exercise, plus the increment I'm adding. The increment here, someone tell me what it is? So what I'm adding on every term? You can unmute yourself right away. So in the previous case, I was adding the numbers, so 1 plus 2 plus 3 plus 4. But in this case, I'm adding 1 over 1 raised to power 4, 1 over 2 raised to power 4, 1 over 3 raised to power 4. So here I'm going to add 1 over k raised to power 4. So term by term. Okay. And maybe a semicolon to suppress it. Then we need to calculate the error, right? And the error, I'm going to call it error. And that error, as we just learned, is the approximate value minus the true value over the true. But the true value is quite, you know, quite a lengthy one. So maybe I should define it here at the beginning. True value equals I raised to power 4 divided by 9. So that's the true value of the series, the sum of the series. Now, our error is going to be the approximation. What's the approximate value here? Is the sum. That's our approximate value. Minus the true value, which is this guy, divided, and I have to put brackets here, right? As we learned at the very beginning about the order of operations, I need to put brackets divided by the true value. And if you wish, you can put the whole thing into big brackets and take the absolute value of it. So ABS is a Matlab function that takes the absolute value. And as we said, to make it a percentage, you need to multiply by 100 at the end. So let's make this a little bit bigger here on the screen. So eventually I need to multiply by 100. Again, naively, I will try here to plot an error. And obviously, this is going to give a mistake, or actually 1 point. Guys, how do I fix this? I need to plot arrays, because if I type plot k an error, and actually let's try it, it's giving me an empty graph. And it's not really empty. There should be 1 point here. But I think it's not clear on the screen. Maybe if we make this with dash black with the squares, maybe, and run it again, you will see 1 square appearing. Yeah, so there's 1 square here. How do I make these arrays? Guys, this is very important. So in major issue in for loops that people are trying to calculate arrays, new arrays, but then when they plot, they end up with plotting one number with one number. How do I get my arrays? Well, first of all, error needs to be an array. So instead of typing error, I'm going to call it error of k, because this time, the Matlab is going to calculate error of 1. That's the first element of the array, which is this term. And then When it loops one more time and calculates a new sum, it's gonna calculate error of 2, and so on and so forth. So that's gonna make the y-axis as an array. But how do I make the x-axis as an array? Again, as we said, k is not an array. You need to define an array, calling it, for example, number of terms, as we did before. So number of terms, last time we made it with length space. This times I can make it this way, from 1 to 100. Now I can plot the number of terms with the error. Just let me label the axes. So X label, I'm gonna put the number of terms, and the Y label, I'm gonna call it the absolute relative error as a percentage. And let's try to run one more time, see what's happening here. So we got something more meaningful. If you guys see the plot that came up to the screen, I have the absolute relative error as a percentage. It starts about, 7.6%. It drops after 2 terms to 1.8%, and then 0.6. You can keep tracking the error, the magnitude of the error by the mouse, and then eventually it goes to a very small number. Not sure if it's gonna display it here. So if we stop here, it's gonna go to 3.1 times 10 to the power minus 5. You see the error is very, very small, 10 to the power minus 5. One last thing, it was requested in the question, but we didn't address, and it's actually clear why we need it. Look, if you look at the values of the error starting from here to the end, all of them, they look like 0. Although they are not zeros. They are small numbers, but they are not zeros. And your eye is not able to see what's happening here. So one way to resolve the values of the y-axis in a clear fashion is to make the y-axis written in log scale. And if you go to the question statement, it says, let me bring the statement again. It says, make the y-axis logarithmic scale and the x-axis linear scale. Okay, so MATLAB offers you this possibility. Instead of plot, you're gonna use semi-log y. In other words, you are telling MATLAB what does semi-log y is doing. Let's write a comment here, actually. So semi-log y makes the y-axis logarithmic. It's gonna keep the x-axis linear. Similarly, semi-log x makes the x-axis logarithmic. And finally, if you want both of them to be logarithmic, you can use log-log. So log makes both axes logarithmic. Let's try to see how what this is gonna give us. If I hit run, guys, do you see the plot now? Let's bring it here, and actually let me remove all these annotations. The plot here clearly shows the different orders of magnitude. So the error, it starts something close to 10, and then goes to something close to 10 power 0, which is 1, and then goes to 10 minus 1, 10 minus 2, 10 minus 3, 10 minus 4, 10 minus 5. You know, it keeps decreasing by orders of magnitude. So the beauty of the log scale, it makes your eye able to see how the error is decreasing rather than seeing everything as if it's a 0, right? Any question here before we go to the breakout rooms and test some interesting exercise? Any question, guys, on this one? Let's see the participants here. It seems we are doing well. No questions. So if no questions, let's do quickly exercise number 3. It's a very, very instructive one. It's basically said, and it's a very quick one, so it's not gonna take time. You can finish this in 2-3 minutes. It says, write a script that compares the time taken to multiply 2 arrays and store the results in a third array. Each one of them has to have 100 million elements. That's a huge number of elements, okay? And you can generate them by lens space, you know, just to speed up your calculation. So you need to generate 2 arrays by lens space command. Each one of them have 100 million elements. One time you are asked to use Matlab element-wise multiplication of arrays, and one time I'm asking you to use a for loop for this purpose. And to compare the time, how much time on your computer does this calculation gonna take? And I'm asking you to use the tick-tock function in Matlab. It's a very tiny and funny name as well, the tick-tock function to time your calculation, just to show you how this can be done in any code. Suppose I want to see how much time this code is taking. So I can write a tick here, you see, tick with a semicolon. At the very end of the calculation, I can put a tock. And let's test this together just to see how this works. You see, of course, it's generating the graph that we saw before, but it's telling me how much time this took on my computer. So on my laptop, this took 0.3427 seconds, right? Generally, it's a good idea to have a feeling of how much time each piece of your code takes. You might think that this is sort of an overkill, like, come on, we are not all of us are computer scientists who are interested in timing and optimizing our code, but really good programming practice is that if you feel that part of your code is lengthy, taking a lot of time, you should find a way to make it less time. Okay, so I'm gonna stop the share here. And again, the exercise is in the shared link. I'm gonna divide you guys into breakout rooms. How many of you are here? And then I will leave you to work for 5 minutes, and then we come back, finish this exercise, and take a break. All right, let's go to the breakout rooms.